Imagine waking up in the year 1700. The sun has barely risen. The air is cold and damp, and the only sounds you hear are birds, wind moving through trees, and the distant creaking of a wooden cart. There are no engines, no factories, no trains, no electricity. Every single task in the world is powered by one of three things: human muscle, animal strength, or the forces of nature, wind and water. For thousands of years, this was how civilization worked. If you needed to move something heavy, people pushed it, or horses pulled it. If you wanted grain ground into flour, a mill turned slowly beside a river. If there was no river nearby, someone had to grind it by hand. Energy was scarce. And because energy was scarce, productivity was limited. A farmer could only plow so much land. A craftsman could only produce so many tools. A weaver could only make so much cloth. Life moved at the pace of human bodies, or the forces of nature, wind and water. But beneath the surface of this quiet world, a transformation was slowly beginning, a transformation that would reshape the planet. And at the center of that transformation was something simple: water, heat, and pressure, steam. To understand why steam engines were invented, we need to travel underground, deep beneath the earth. In the mines of 17th century Europe, coal was becoming increasingly valuable. Cities were growing, homes needed fuel for heating, iron production required enormous amounts of energy, and coal was the answer. But coal mining had a major problem: water. The deeper miners dug, the more groundwater flooded their tunnels. Soon, entire shafts would fill with water. Work stopped, mining became impossible, and removing that water was extremely difficult. Workers used buckets, pumps powered by horses, even complex systems of wooden machinery. But none of these methods worked well for deep mines. Mines kept flooding, coal stayed trapped underground. And this crisis forced inventors to search for a new solution, a machine that could pump water out of mines, not using animals, not using human labor, but using a completely new source of power. In 1712, an English inventor built a strange and revolutionary machine. His name was Thomas Newcomen. His invention became the first practical steam engine. But compared to modern engines, it was enormous, slow, and inefficient, and yet it worked. Here is how the machine operated. First, a boiler heated water until it turned into steam. That steam flowed into a large vertical cylinder. Inside the cylinder was a piston. The steam filled the chamber and lifted the piston upward. Then cold water was sprayed into the cylinder. The steam instantly condensed back into water, and this created a vacuum. Atmospheric pressure forced the piston downward. Up, down, up, down. Each movement powered a pump deep in the mine. Water began rising out of flooded shafts. For the first time in history, a machine, not animals, not humans, was doing the work. It was the birth of mechanical power. But there was a problem. The machine wasted enormous amounts of energy. Every cycle required heating and cooling the same cylinder again and again. Fuel consumption was huge, and coal was expensive. The steam engine worked, but it needed improvement. Decades later, a young instrument maker in Scotland was asked to repair a small model steam engine. His name was James Watt, and that repair changed history. Watt noticed something strange. The engine constantly heated and cooled the same chamber. It was incredibly inefficient. So Watt asked a simple question: what if the steam condensed somewhere else, instead of inside the cylinder? That insight led to one of the most important engineering breakthroughs in history: the separate condenser. Steam powered the piston. Then it moved into a separate chamber where it cooled and condensed. The cylinder stayed hot. Efficiency skyrocketed. Fuel consumption dropped dramatically. And suddenly, the steam engine became practical for many industries. Not just mining, but inventions alone rarely change the world. They need entrepreneurs. And Watt found the perfect partner: The man who helped bring Watt's invention to the world was Matthew Boulton. Boulton was a businessman with vision. He owned a large manufacturing complex in Birmingham. Together, Watt and Boulton began producing improved steam engines for mines, mills, and factories. Their partnership became one of the most important collaborations in technological history. Steam engines began spreading across Britain, pumping water, grinding grain, powering machines, driving industrial production. For the first time in human history, energy was no longer limited by muscles or rivers. It could be generated anywhere, as long as there was fuel, coal. And Britain had a lot of coal. This was the beginning of a chain reaction. Steam engines made mining more efficient. More coal became available. More coal powered more engines, and the cycle accelerated. Humanity had unlocked a new level of energy. The next revolution happened inside factories. Before steam engines, factories had to be built near rivers. Water wheels powered machinery. But rivers had limitations. Water levels changed. Droughts stopped production. And factories were tied to specific locations. Steam engines changed everything. Factories could now be built anywhere. Cities, industrial districts, transportation hubs. Machines began spinning cotton, powering looms, hammering iron, driving massive mechanical systems. Entire buildings filled with moving gears, belts, and pistons. For workers entering these factories, it felt like stepping inside a giant living machine. Noise thundered through the air. Metal clanged, steam hissed, and production soared. Goods that once took weeks to produce could now be made in hours. The industrial age had begun. At first, steam engines were stationary. They powered pumps and factory machinery. But inventors soon asked another question. What if steam engines could move? The answer would transform transportation forever. One of the pioneers of this idea was George Stephenson. Stephenson developed powerful steam locomotives capable of pulling heavy loads. In 1825, the world witnessed a revolutionary event, the opening of the Stockton and Darlington Railway opening. It was the first public railway to use steam locomotives. Crowds gathered to watch the strange iron machine roar down the tracks. Smoke poured from its chimney. Steam blasted from its pistons. And the locomotive pulled dozens of wagons behind it. For centuries, the fastest land travel had been horseback. Now machines could move faster and pull enormous weight. Railways began spreading across continents. Distances shrank. Trade accelerated, and entire economies reorganized around rail networks. Steam engines didn't just transform land travel, they also revolutionized sea travel. For thousands of years, ships depended on wind, but wind was unpredictable. Journeys could take weeks or months longer than expected. Steamships changed that. One of the early pioneers was Robert Fulton. His steamboat demonstrated that steam engines could reliably power vessels. Soon, steamships began appearing on rivers and oceans. Trade routes became faster and more predictable. Travel times shrank dramatically. Transatlantic voyages that once depended entirely on wind could now run on fixed schedules. Steam engines had connected the world in a completely new way. By the late 19th century, steam engines were everywhere. Factories, railroads, ships, mines, steel mills, even early electricity generation plants. Steam engines powered the machinery that built modern civilization. Rail networks linked cities. Industrial factories produced goods in massive quantities. Steel, bridges, and skyscrapers rose above growing urban centers. Global trade expanded rapidly, and populations exploded. Steam power had multiplied humanity. I's ability to produce energy. In fact, historians often describe the steam engine as the first machine that dramatically amplified human power on a global scale. Before steam, energy production had been limited. After steam, it grew exponentially. This shift transformed economics, politics, and society. But it also came with costs. Industrialization was not gentle. Factories demanded long hours. Workers labored in dangerous conditions. Cities became crowded and polluted. Coal smoke darkened the skies. Rivers filled with industrial waste. Entire landscapes changed. The machines that powered progress also created new social challenges. Child labor, urban poverty, labor exploitation. These problems eventually sparked political movements, labor unions, social reforms, new laws protecting workers. The industrial world had created both incredible wealth and enormous inequality. Steam power had changed everything. But humanity was still learning how to live with its consequences. Today, we rarely think about steam engines. They seem old, obsolete, but their legacy surrounds us. Modern power plants still use steam turbines. Electricity generation still relies on steam to spin massive generators. The principle discovered centuries ago remains fundamental to modern energy systems. Steam engines also laid the foundation for mechanical engineering. They inspired new machines, internal combustion engines, automobiles, airplanes, industrial automation. The entire technological world we live in today traces part of its lineage back to the first steam engines. A machine invented to pump water out of mines ended up transforming the entire planet. For most of history, humans lived within strict limits. Limits of muscle, limits of wind, limits of water. But steam changed those limits. By converting heat into motion, humanity unlocked a powerful new tool. Energy could now be generated anywhere, on demand, at scale. And once that door opened, it never closed. Steam power was only the beginning. Electricity, oil, nuclear energy, renewables. Each technological leap built on the foundations laid during the age of steam. And it all started with a simple observation. Heat creates pressure. Pressure creates motion. Motion changes the world.